Hi everyone, and welcome to a brand new podcast from Teletrac Navman, Mobilizing the Future of Fleets. It's a podcast dedicated to helping fleet and transportation businesses navigate the roads ahead. I'm Barney Goffer, Product Manager for Fleet Energy Solutions at Teletrac Navman, and joining me today is a leading global authority on the subject of EV, Special Advisor to the UK Government and founder of Zero Carbon Futures, Professor Colin Heron. Professor Heron notably spent 17 years at Nissan, where he was instrumental in the rollout of the Leaf, the world's first mass-market electric vehicle. Also joining us is Peter Crow, European Sales Manager at Angie Energy Systems, a specialist in alternative energy solutions. Peter has worked within the compressed natural gas industry for 40 years in development, service and sales roles, and across markets including Europe, Asia and North America. Good to have you with us, gents. So today we're going to be discussing mixed energy types and the various arguments around them. Now, according to last year's IEA report on the World Energy Outlook, it predicts that 2030 will see the peak for each of the fossil fuels. So what are the alternatives? Colin, I'll come to you first with this one. The IEA predicting that electrification will dominate transportation. Is that a fair statement, or are there likely to be alternatives out there?
There will be alternatives, and there has to be alternatives. I think the reason that electric vehicles are being seen as dominant now is policy setting this. And the vehicle makers have to make a call because it takes so long to develop a platform and so long to put the supply chain in. They've had to basically pick a winner and one that they know. So in the short term, I think it's going to be heavily electric. But we all know combine harvesters and other vehicles, they're going to be exceptions.
If we think about heavy duty transportation, and Peter, maybe you want to come in here and talk to alternative energies and where you see the market playing a part in the energy transition as well.
So the market is moving fast. Certainly within the last 5 years, we've seen a huge uptake of different vehicle technologies becoming available and available to the open market. If we went back 5 years ago, even a fleet manager would make a simple decision. The fuel is either going to be gasoline or diesel. Today it's a more complex market, and one that has to be considered even from board level down. Once upon a time it was just delivering goods was the key. Now it's meeting other criteria such as saving carbon, being able to demonstrate that to their shareholders. So of the different technologies that are out there today, there is certainly natural gas in the form of CNG or LNG. Hydrogen is rapidly developing alongside using cleaner liquid fuels. And there will be different fuels for different applications, which I think we've already mentioned.
So when you touch there on those alternatives, they're often described as scaling technologies. What are the barriers that they've got to overcome?
So carrying sufficient energy on a vehicle to do a day's work is one of the challenges that's out there. Diesel, if you've got a diesel tank, to carry the same amount of energy in CNG form, it's going to be 4 times the geometric volume. Make that LNG, it's half the size. But then you've got the consideration of how to get the energy to the point of sale.
Yeah.
And that's another consideration. And who's going to actually manage that?
Sure. And what about cost? Where does cost come into this as well? Because from everything that we read in the press and according to industry experts, electrification seems to generate a reasonable and sensible return on investment. Where are the alternative energy markets in relation to cost, and how can it compete with EV?
Well, that's another rapidly changing area. If we consider natural gas delivered through a pipeline, that's certainly comparable with diesel, and possibly there is a saving to be shown as well. The other fuels are developing, and I don't think we can actually put a price or a cost to them today. But one thing we do know is that fleet operators are driven by cost. Margins are very tight, and so they have to have a solution which is economical to operate.
Yeah, absolutely.
Could I throw something in on this, which might sound very strange, but electricity, the pricing of electricity varies. The price of diesel during the day doesn't, okay? At night, there is a lot of surplus electricity. Just for instance, we might see all of our HGVs moving to night movement, where the electricity could be almost free.
Yeah, absolutely. I think this is something we wanted to get onto later on in the podcast in terms of the different business models that might exist. Particularly if you think of the energy you've got in a battery like cash in the bank, you can probably start making that work for you. So there's revenue generation opportunities through electrification, right?
And the other thing which is the legislation of what is determined as a zero emission vehicle. That is going to drive decisions, not costs as well. It's got to be both. So if an HDV has to have zero tailpipe emissions, there's only two alternatives. At the moment, it's just fact, unless we have a nuclear powered HDV.
Sure. Okay. So that puts a challenge in the way to alternative energies in terms of CNG, LNG. Is that what you're saying, essentially? Okay. And in terms of other challenges that the EV market still has to overcome, what are they? Because it's not this panacea that perhaps is perceived to be. What else needs to be dealt with in terms of mass market adoption?
One, we need to make them, and they're not being made in the volume. Two, you need the infrastructure, which is starting to go in. Germany, the Traton Group, are investing €500 million in about 1 megawatt, 1.5 megawatt chargers across. We're already got GridServe in the UK running out trials of these high power chargers, but there simply isn't the battery and the supply of vehicles yet.
Yeah, and that's going to take time, investment to actually get there. How far away are we from it being a reality then?
The technology is not a problem. It's the rollout of the technology.
Yeah, and then in relation to the same question, Peter, really, in relation to alternative energies, if we think about the parallels here and the challenges of distribution and infrastructure, where is the alternative energy market for that? Maybe there's some use cases or examples you'd like to talk to.
So I think I'd like to bring one issue up first, which is commonly confused, and that's global warming concerns and tailpipe emissions. And just because you're running a zero tailpipe vehicle doesn't necessarily mean that it is particularly good as far as global warming is concerned. So how is the energy produced? If it was a biomethane going into vehicles, then that's produced from anaerobic digestion, and it could actually be called carbon negative. And it's then transported through an existing network of pipes to the point of use. So we're actually taking transport vehicles off the road, delivering fuels to a point of use in the same way as you do with battery electric. But that will never be as clean as perhaps a hydrogen vehicle or a battery electric vehicle. So they're different. The next challenge, of course, is if you're looking at hydrogen vehicles, is getting hydrogen, clean hydrogen, to the point of use. And there are different models being looked at around the world, either transporting it in a liquid form or a gaseous form. And then once you've got it to the point of sale, then transposing that into the vehicle is a relatively simple thing to do. It's technology that we're currently using for the CNG market that is just adapted for a different fuel.
Sure. So we're saying the production process here for green hydrogen is actually one of the key challenges to overcome here, right? Actually not burning coal or gas to actually produce it, using electrolyzers and the investment that's needed to go into that. Where is that in terms of solving that problem, and how scalable is it today, and what needs to happen from an investment perspective to make that a reality?
The big problem with hydrogen is the efficiency losses.
Yeah.
It's just huge, and that's the big problem. And in simple terms, if you need a wind turbine for an electric truck, you need 2.5 wind turbines for a hydrogen truck. That's the big problem. You lose so much power on it. The last time I looked at HDV registrations in the UK for hydrogen, it's 0. It's a long way behind. It's a long way behind. Yes, it works, but whether we can take the efficiency loss and the costs, they are quite expensive to service and look at.
I mean, that's the view of where we are at in the UK. I think we'll get an alternative opinion on where we're at globally on this. And Peter, if you want to share something on that as well.
So within Europe, there are developments to the blue corridors to introduce hydrogen refueling stations. And it's a programme which will install stations capable of delivering 3 tonnes of gas per day. So that's the start of the process. And then we've got most of the major truck manufacturers are pursuing a hydrogen product. And in North America, we are delivering refueling equipment for a major truck manufacturer who will have equipment operating within the next couple of years. So it is moving forwards.
Yeah, it's just clearly behind, but there's a journey that it's on, and we're expecting to see these vehicles on the roads of Europe, the UK, the US, and well, everywhere, quite frankly. Okay.
And there is the political will, both in North America and in Europe, to drive towards zero tailpipe emissions.
Yeah, indeed. Okay, so policy's driving that change. What are the risks, Colin, with the rapid adoption of electrification? Because it's moving so quickly by comparison to alternative energies.
The risk with the technology is very low. It's quite simple. You know, it's a battery. You just drive it as normal. I suppose the risk is that there are targets which are being set to be achieved. I think the big problem is actually having everything in place to achieve those targets when we're supposed to do it. And it's the definitions and the targets which are driving the behaviour of the vehicle manufacturers. They've also got to keep the customers happy.
Yeah.
And one of the things about logistics, and if we go back to the COVID era, I was speaking to one advisor at the government, and I hadn't realised in COVID the biggest fear was we wouldn't have the HDVs would stop running. The drivers would stop operating. If you have that situation, the UK collapses, Germany collapses. And it's become very, very clear, if we are setting a mandate for zero emission vehicles at a set point, if we do not have the infrastructure and the vehicles at that point, what do? We either have to go back to diesel, but we stop making them.
It's not an option though, is it? Sure.
So the private motorist like me, well, okay, I may have a problem, I can't, etc. But the road haulage industry is a different thing. It has to be sorted. The infrastructure, and I know the SMMT and people are really taking this seriously.
Yeah, it's come up, it was in the news only recently as well, wasn't it, in terms of the missed targets that we've got for high-powered charging infrastructure being deployed at service stations along the motorway network. So there's clearly some gaps to actually close. I think, and don't quote me on this, we were at 50% of the expected target. So how do we overcome that then? What's holding us back here in terms of getting there?
Here's another discussion point. Our motorway services might just happen to be in the wrong place. Mm-hmm. They're not where the power is. They were never designed for the amount of power. So the government targets and what the government's got to do is not provide lots of high power chargers at motorway services. The private sector will do that. We need the power cables there.
Yeah.
And that is what we need to do. We need the power cables. So whether it's we're making hydrogen at the filling stations or we're filling trucks, we need the power. And without the power, you can't hit the targets.
Yeah.
So it's not the infrastructure, it's not the will to put them in, we need the power. We've got the power, we just haven't got the copper.
Okay, so I think the catchphrase that I hear used quite often is there's no transition without transmission. And we'll come on to that later when we talk a bit more about infrastructure as well. So lastly, on this piece here is the relationship between EV and hydrogen, and whether they actually live together harmoniously or whether the two are actually incongruous. But is there a future of where the two actually support each other in the existence of energy transition, and what is that, and how does that actually work?
I think the answer to that is yes. But we don't know exactly how that will develop, because battery technology is moving at a very fast pace. And we need further development in the availability of hydrogen trucks.
Yeah. Is the use case actually within storage? This is stuff that I've been reading upon, that I hear the relationship of using hydrogen to actually support the energy network from a storage and a battery capacity perspective.
There is one small problem with the laws of physics, is to make hydrogen, you need energy to split the hydrogen off. You're stuck with that. If you use hydrogen to store energy, you lose a lot of energy to make the hydrogen, and then you've got to convert it back. It's a very good way of losing a lot of what you want to store. I can see there will be some use for dual fuel, some burning hydrogen in big trucks at some point, yes. Yeah. And I don't think until we get solid state batteries or some technology move, there will be circumstances where really big trucks. I just don't understand how you would have a tank transporter with a Challenger 2 tank going down the M1 with a battery truck at the moment. It just doesn't make sense.
Mm-hmm. And then we've spoken quite a lot about hydrogen there, Peter, but what about the other alternative? We've got RNG, there's CNG, there's LNG. What are the use cases in the UK or globally where that's actually working today? Because there are some, right?
Certainly in the US and even in the UK, there are 44-ton trucks running around on CNG with a natural gas engine dedicated to operate on natural gas very efficiently and very cleanly. And it's a fuel that's available now. The technology is well proven, well demonstrated, and provides a reliable product at a reliable cost. And that's what the operators like to use.
The UK is different in a way. So a lot of our big trucks, in the instance in my region, go from Nissan to the Port of Tyne to Nissan to the Port of Tyne, Nissan to the Port of Tyne. It's a set route and they do about 40 miles, 50 miles a day. That's not a problem. Driving across America,
Completely different.
or Australia, etc., for me it's long haul HGV versus a milk run type HGV. Milk run HGVs will be electric. It's just, they will be electric.
Yeah.
It's easy to do. You can buy them now, you can buy them from the showroom, get on with it. Whether people who put these high power chargers and all the power in will then say, well, we might also put the equivalent power and the network in for some hydrogen trucks, that's to be seen.
Yeah, so we're saying here that geography will play a huge part in this in terms of distances travelled and range requirements, and we don't really know what that looks like, right?
And the application of the vehicle.
Yeah.
Because you can refuel a gaseous vehicle in the same time as you can a liquid fuel vehicle. Whereas it takes a little bit longer with a battery electric vehicle. And that is a different method of operation. Whether you could move all of your vehicles onto operating at night, I suspect that's not the case. So there will be applications where gas plays an important part.
Just something that I want to revisit, and that's the relationship between electric vehicles, fuel cell vehicles, and the use cases here. Can you tell me your thoughts on the applications, particularly within heavy duty transport, maybe off-road? What's best suited to that?
Can we just use the word hydrogen as well? And
Yep.
we need to move to fuel cell vehicle, which is electrolyzed, produced hydrogen, which is very pure. Mm-hmm. And the other is where we're using hydrogen in a combustion mode. So at the moment, some big off-road and heavy truck engine producers are looking at burning hydrogen as opposed to fuel cell vehicles. When we go to companies like Caterpillar, Komatsu, they're saying that the small vehicles, which are potentially used in gardens or on the street, will probably be electric. Then when you move up, it could be fuel cell or it could be burning hydrogen for the application which they used. So probably with the HGVs and off-road, the answer is yes, yes and yes, dependent on the application.
No, I think that's right. So range is going to be critical on some applications, and that would generally lend itself towards a hydrogen fuel cell vehicle. And the speed at which you can refuel that vehicle is likely at the moment to be quicker. So you could refuel in under 15 minutes for a 44-ton application.
Right. When, if we take those examples there, when do we expect to see that being viable and widely used? Then let's take the off-road example. That seems like a sensible place to start that discussion.
The one company, Komatsu, have announced the 20-ton prototype, which they're putting in the market to test. Mm-hmm. So they're already doing that. I know JCB have produced electric backhoe small vehicles. JCB are also announcing engines which will burn hydrogen, and we know Cummins are doing that. So they're in the trial phase of actually producing it. Again, there's consequences in each to the location. If you're in the middle of Africa and you're trying to dig a hole, is electric going to work? Probably not. So again, we're down to where is the vehicle going to be used? How much energy does that vehicle use up in a set period of time before it has to be refilled. So the trials are on the way. I've seen some really big mining equipment that's all electric, which has defied what I thought would happen. But in other circumstances, that might not be the case.
Absolutely. Okay, great.
Policy will finally make a decision, and cost operating will finally make the decision. But within Europe, there are decisions being made on Euro 6 vehicles. The next standard, whether that will allow carbon neutral fuels, or it'll be forced down the route of hydrogen and battery electric. The same with CO2 emissions on light vehicles and heavy vehicles. Light vehicles is already determined, heavy vehicles is yet to come, probably within 2025. And then we've got a likely change of government within Europe within the next 12 months, and that might change everything again. So we just don't know. What we do know is that we have all of those solutions available.
This is what I was going to sort of sum up the conversation here, is that there's options out there. It's not necessarily one or the other. It's about finding the right use case and best fit solution for like you say, Colin, the geography and the work that's actually being done.
But we will have those options in what you could call the Western world. Mm-hmm. These manufacturers also have to operate to places we've been, Central Africa. They're going to have to produce product which will operate in environments which are unique and completely different to England or in certain areas of Europe. You cannot compare the environments and the resources which are available.
Yeah, indeed. I know statistically, when we look at what maybe 2050 looks like, any of the analysts seem to, clearly call out that, internal combustion engines still going to form a significant part of what we do in terms of how we move around and transport goods, regardless of how the advancements of electrification and alternative energies, impact that market. So, those alternatives are going to be around for a long time, right?
I visited, I've not named the country, but it was a Central African country. The cars are 98% Toyotas. Yeah. Literally, every car, because they know how to fix them. There is no chance of them adopting an electric Toyota. Mm-hmm. The grid can just about keep the lights on.
We are seeing in Africa, we're seeing truck manufacturers funding biomethane production, refueling stations, so they can supply their trucks, and that's happening today.
Any closing comments, gents, on this particular topic? Feels like the future's fairly eclectic in terms of energy solutions for transportation, despite the fact that EVs are at the forefront of it at the moment, but there's certainly alternatives out there that need to be explored, right?
Absolutely, and for me, I monitor what the vehicle makers are making, not what they say. Mm-hmm. So if they suddenly convert a plant, Scania converts a huge plant to hydrogen trucks, they're coming.
Yeah.
Regardless of what the policymakers say.
The consumer will only buy what's made, right? So if it's, absolutely. Yeah, makes sense. Thank you for joining us for the podcast, and thanks to our guests, Professor Colin Heron and Peter Crow. We'll see you on the next one.